Hello everybody, we are back for more derivatives. So far, we know the power rule, how to take the derivative of e to the x, what to do with sums and differences, and what to do with products. Today, what we need to talk about is what to do with our buddies, the quotients. In other words, when we have a rational function, when we have a fraction. Everybody's favorite rule, the quotient rule. Okay, so I'm going to give you the quotient rule in math speak, and then we will worry about what the quotient rule looks like with hearts and clouds. Okay, again, please don't be intimidated by it in math speak. It's just one we have to memorize, but I have a couple ways to show you to memorize it so that you can get it in your brain. All right, so it starts just like the product rule does. If u and v are differentiable functions, then their quotient is also differentiable. So as long as the two pieces, the numerator and the denominator, are differentiable functions, we can take a derivative. And here's what it looks like. Again, write it down. Don't be intimidated by it. We'll memorize it here in a moment. If the derivative, if your function looks like a u over a v, notice we start in the denominator. The top looks like a product rule with one difference. There's a minus. There's a subtraction here. Because there's a subtraction, it becomes important the order in which we do things. If you remember with the product rule, I said I do it one way and pretty much everybody else in the world tends to do it in the opposite order. And it doesn't matter because it's an addition. With the product rule, that's true. With the quotient rule, it's not. It's a subtraction up here, so it's going to matter what order we do this. And then the denominator is your old denominator, but squared. So notice it starts with your denominator multiplied by the derivative of your numerator, and then the opposite over here, your numerator multiplied by the derivative of your denominator. But it's a subtraction, so this order matters. So that's what it looks like in your calculus notation. We're not even going to look at it with a du dx in here and a dv dx because that's just way too ugly. Right? Here it is with hearts and clouds. If you have a heart on top and a cloud on the bottom, again, you're going to start on the bottom, so it's your bottom, or your denominator, derivative of numerator, minus numerator, derivative of denominator, over your denominator squared. That is the quotient rule. That's the pattern we're going to follow anytime our function is a quotient. Okay. And again, the top looks a lot like a product rule, and the most common mistake there's two common mistakes people make. The first is flip-flopping that numerator, which I'm going to try to help you memorize it so that you don't do that. And the other is just getting so darn excited that you're done with your numerator that you forget to put the denominator squared. So to do that, I usually write that part first because there's no calculus involved in that. Notice it's not the derivative, it's just cloud squared. So I usually write that part first, and then I worry about my numerator. I'm going to show you this other way to memorize it. I hate this so much, but other people seem to like it, so I'll show it to you. They say you're looking at your function as high over low. So high being the top of the function, low being the bottom of the function. Never mind that this is not how you spell high when something is up high, but whatever. Okay. So they say, again, you're starting low. So low, d high, the derivative of your what's up top, minus high d low, the derivative of what's on the bottom, over low squared. So the top is red, low d high minus high d low. And for some reason, the people like that. I hate it because what's to help me remember that low comes first is my whole point with this. So I understand that low d high minus high d low is nice and it sounds cute, like you're yodeling or something. Okay, cool, whatever. But how are you supposed to remember that low comes first? And that's where I come in. Because I have a way to remember that low comes first with my quotient rule playlist. So allow me to play. Which one should we play first? Know the song? Can you hear it? Where's my speaker? You ready? Get low. To the wall. song is called Get Low. Do you hear me? Get low. You gotta start low and you end low. Get low. Okay, now last year they pointed out to me that I could add another song to my playlist. So if this one helps you, if you like this one better, a little Flow Rida. The whole point here is when you start the quotient rule, you start low. You're welcome. Point here being, the quotient rule starts low and it ends low. If you're starting in the numerator, you better be starting with the bottom. And when you finish it off, at the end, it finishes low. So you start low, you end low, you get low. And if that helps you, when you go to homecoming, and they come back from homecoming and they say, Miss Britton, they played the quotient rule song. And I'm like, that's right, they did. They did. And you danced to it, and you know what? You thought about calculus at homecoming and prom. And every time you hear that song for the rest of your life, you're welcome. So I don't care how you remember it. If you want to remember it using T-Pain, if you want to remember it using Flow Rida, if you want to just memorize it in the calculus thing, doesn't matter to me. It matters to me that you remember the quotient rule. And that is denominator, derivative of numerator, minus numerator, derivative of denominator, over denominator squared. Translation, get low. Let's do one. Okay, now, this first one, just like the product rule, completely avoidable. The quotient rule is 100% avoidable here. All you have to do is reduce this. You won't really actually... Oh no, never mind. Yeah. Lost myself there for a minute. I'm still singing a song in my head. If you could reduce this, it would be 1 over 3x, and you could take the derivative. You could rewrite that as 1/3 x to the negative 1. Now, you probably don't want to do that because you hate two things, fractions and negative exponents. But you could reduce that, rewrite it, and get, when you do the derivative, negative 1/3 x to the negative 2, and be done. Right? But again, why would we do that when we could be so extra and use the stinking quotient rule? Okay. So if I use the quotient rule on this, I have my numerator and I have my denominator. So the quotient rule says, again, I cannot overstate this, get low. I'm always starting down. I'm starting with my denominator and I'm finishing with my denominator. So denominator, derivative of numerator, so I'm going to need that numerator prime, then minus the opposite of that, numerator and denominator prime. So if you can remember to start and finish with your denominator, get low, then you won't forget the quotient rule. So for this one, all I have to do, once I have it written out like this, is pop my pieces together. So my denominator is 6x cubed. My numerator is going to be, or my derivative of my numerator in this case will be 4x. My numerator, 2x squared, times the derivative of my denominator, 18x squared, over my denominator squared, which is 36x to the 6th. And I want to point something out to you. Obviously, calculus is magic. 24x to the 4th minus 36x to the 4th is negative 12x to the 4th, right? Down here you have a 36x to the 6th. What's that reduced to? 1 over 3, and you have an x squared in the denominator, which is exactly what we got when we reduced it and did it the short way. Now, I will say a lot of people avoid the quotient rule when they can, because the quotient rule is a lot. So a lot of times people will take a quotient rule and rewrite it as a product rule because they don't want to do the quotient rule. And that's fine. So for example, here, I could avoid the quotient rule by rewriting this as e to the x times 1/6 x to the negative 3rd. Siri doesn't understand the quotient rule. Excuse us. You don't have to understand Siri. Okay, so you could rewrite this and avoid. I could just pull this x up with a negative exponent and do this as a product if I wanted to. Okay. For me, it's usually not worth it. Like, never mind, I'll just do the quotient rule. I don't really think it's that big of a deal, but some people really go out of their way to avoid it. Okay, so if we aren't going to avoid it because we're practicing it, again, I have a numerator and I have a denominator. And if that's all you have, a numerator, denominator, get low, you get your derivative. Okay, so again, I'm going to start low, I'm going to end low. So I need my 6x cubed times the derivative of my numerator, easy derivative here, thank you very much, minus my numerator, derivative of my denominator, so 18x squared, all over my original denominator squared. Now you can write it like this to make sure you don't make any silly mistakes, or you can write 36x to the 6th. But again, if I'm not doing anything with this derivative, there's no way I would square that because I don't want it touched, right? I'm not risking making any silly mistakes. If I need to do something with this, like figure out where it equals 0 or where it's undefined or whatever, then I'm probably going to want to simplify. But otherwise, you can leave it right like this. Okay, in this case, you could do some cancellations and some other good things. All right. In this example, I cannot avoid the quotient rule. Okay. There's no way I can just like, oh, let me just rewrite this. Remember, you can't break it up with these individual pieces in the denominator. You couldn't make like 3 fractions out of this and reduce, and don't even think about it. This is straight quotient rule. You don't have a choice. You have to use it. So again, it's all about what's in my numerator and what's in my denominator. All right. So I need to start low and finish low. So it's going to be cloud rectangle prime, and then over here the opposite. Again, this rule is just something that you have to memorize. You already memorized it though, because you're still singing in your head. I know you are. Okay, so when we put that together, so my denominator completely untouched. Notice my use of parentheses here is absolutely mandatory. Otherwise, you would not be foiling all this out. So denominator, the derivative of my numerator, is just 5 in this case. That's a nice linear function. Minus my numerator times the derivative of my denominator, which in this case is just 2x plus 8. All over my denominator, untouched, x squared plus 8x minus 2. Quantity squared. Okay. Again, I am not simplifying this unless I have to. Now, we might be in a situation where we do need to simplify it. If I need to know where this is 0, I'm going to have to FOIL this out, simplify this polynomial, and find its zeros. But if I'm not being asked to do that, bye-bye, we're leaving it right like it is. Okay, just like for the product rule, again, AP is going to come at us. Oh, hello. AP is going to come at us with table problems that are in the abstract. They want to know if you know the quotient rule. They don't want to know if you know how to use a calculator. So notice here that they defined a function, function P, as a quotient, as function R over S, and then they give us some information about R and S. So the first thing that we need to do if we want to know, if we want to answer questions about P, it's funny that it's PU, is find the derivative generically of this. So again, we are going to get low. So I'm going to start with S. That's going to be multiplied by R prime minus R, and then times S prime over S squared. Notice I didn't write the of u every time because it just makes it look messy, and this is a fine way to do it. Nobody's going to, you wouldn't like lose any AP credit or anything like that for not writing the of u part. All right, so if I want p prime of -1, then I just need to go pull those values. So I need s of 1, I need r prime of 1, whoop, -1, sorry. I need r of -1, I need s prime of -1, and then I'm going to be s of -1 squared. Right? So at that point, it's just a matter of going and getting the values out of the table. So s of -1 is -1. R prime of -1 is 4. R of -1 is 2. S prime of negative 1 is negative 3. And that's going to be all over S of negative 1 squared. So, oh, that's nice, all over 1. So I have negative 4, and notice this is negative, but I have a subtraction, so it's plus 6. I don't know why I'm always entertained when an answer comes out to 2 in calculus. It's like you do all this work and you get 2 as your answer. I don't know why, but I think that's awesome when that happened. Okay, so again, you can't get around this if you don't know the quotient rule, and this is what the AP is after, right? They want to know if you know the quotient rule, so they're going to ask you questions in the abstract like this. But that is pretty much it for the quotient rule, right? It is, again, I cannot stress enough, it is just a rule that you need to memorize. You can't get around memorizing it, just like the product rule. It's similar to a product rule, so you have to be really, really careful with the quotient rule about what order you do things. Just remember to get low. See you next time.